All right, so now that we have a handle on cylindrical coordinates, we're going to talk about spherical coordinates. So in a spherical coordinate system, a point P is represented by the ordered triple rho, theta, and phi. Those are all Greek letters, where rho is the distance between P, your point, and the origin. So because rho is in terms of distance, we know rho can't be negative. Theta, well, theta is the same thing as it was in cylindrical. Theta is the same angle used in cylindrical coordinates. And then this other coordinate, phi, is also an angle. It's the angle between the positive z-axis and the line segment OP, where O is the origin. And we also know some information about this angle phi. In particular, it's between 0 and pi. So let's look at a picture here of what's going on, what these angles all appear like. Where do they come in? So here's X, Y, and Z. And let's say I have my point P is out here. So the first thing is rho. Rho is the distance. So if I go from the origin to my point P, so my origin O, that length of that side, that is our rho. Now remember, to get theta, what we do is we project this point down onto the XY axis. And then to get theta, it's the angle between the positive x-axis and that line segment from the origin to the projection. And then finally, we have one new angle, which is rho, and it's the angle, it's phi. So let me move this rho label. Rho is that length of that segment there. Phi is the angle from the positive z-axis to the line segment OP. So because you're going from the positive z-axis down, you're only getting the angles between 0 and pi. All right, so then again, what I want to know is how to convert. Now I have three different systems. I have spherical, I have cylindrical, and I have rectangular. So let's talk about how to convert between all of these. So if I'm looking at spherical to rectangular, my conversions look like x equals rho sine phi cosine theta. Y will be rho sine phi sine theta, and z will be rho cosine phi. So these are how I convert from spherical to rectangular. How do I convert from the other way, from rectangular to spherical? Well, I'm going to find rho. Rho squared is x squared plus y squared plus z squared. Theta, you find it the same way as you did before, y over x. And then phi will be the inverse cosine of z over the square root of x squared plus y squared plus z squared. So these tell me how to convert from rectangular to spherical. Now what if I wanted to switch between spherical and cylindrical? I'll mention that real briefly. So from spherical to cylindrical, r squared would be rho squared sine squared phi. Theta would be the same in both, and z would be rho cosine phi. And then switching from the opposite, cylindrical to spherical, rho would be the square root of r squared plus z squared. Theta would be the same in both. And phi would be r cosine of z over the square root of r squared plus z squared. So let's kind of mention why you would want to have spherical coordinates. What are they useful for? So again, the name kind of gives it away. Spherical coordinates are useful for surfaces with a point or center of symmetry. So, for example, a sphere. A sphere has symmetry around its center, and it has a really nice equation in spherical coordinates. So if you take a sphere that's centered at the origin, if I convert it into spherical coordinates, the equation becomes rho equals some fixed number c, and that's a much more simplified equation for a sphere than it is in rectangular.